Venice, the picturesque city of Italy, is composed of 118 separate island groups which are surrounded by the Venetian lagoon. While the city has been the scenery of many romantic and action films, the hot, humid winds originating from northern Africa lining up with the moon's gravitational pull make Venus face a unique yet cumbersome problem. The seawater from the Adriatic Sea is pushed into the Venetian lagoon. This flooding of the city is known by the locals as acqua alta or high water. In the past, flooding used to affect only 10% of the mainland, particularly St. Mark's Square. The year 2018 marked the worst floods for the stricken city in history, with around 75% of the city being affected in one way or the other. The higher-ups in the Italian government were compelled to speed past opposition from left groups and allegations of embezzlement of funds to invest $7 billion American dollars to try to find a solution. Enter the MOSE. The experimental electromechanical module, simplified as MOSE, was an intensively designed project to protect the city of Venice and the surrounding Venetian lagoon from potential flooding problems. The project included an integrated system designed with a combination of rows of mobile gates installed at the three inlets of Lido, Malamocco, and Chioggia. Closure of these gates meant the temporary complete isolation of the Venetian lagoon from the Adriatic Sea during the problematic high tides. The system works in cooperation with other measures like coastal reinforcement, the raising of quaysides, and road paving, along with improvement of the flood handling ability of the lagoon. MOSE is tried and tested in its ability to protect Venus and the lagoon from tides of up to 3 meters in height. The name Moses was derived from the biblical Israelite figure who had parted the Red Sea with divine power. The Consorzio Venezia Nuova was awarded the tender for the work on behalf of the Ministry of Infrastructure and Transport. The construction was scheduled to begin in 2003, and on July 2020, the group reported the completion of the first full test. This was after the project was marred with multiple delays, cost overruns, and scandals that made it miss 2 deadlines in 2018 and 2021. The project is expected to be completed by 2025. On the 3rd of October 2020, the MOSE was used for the first time in response to the occurrence of an unusually high tide event and managed to successfully prevent some of the low-lying parts of the city from flooding. The main aim of the MOSE is to protect the lagoon, the towns, villages, and most important, the inhabitants from high water level conditions. A lot of focus was also given to the iconic, historic, artistic, and environmental heritage of the city, which is not very resilient to seawater. The Venetian high tide seen in the lagoon basin is comparatively lower than what is seen in other areas of the world, but can result in devastation consequently for the citizens owing to the low general ground level of the city. This phenomenon, when associated with intense atmospheric and meteorological factors like low pressure and the African BORA, a northeasterly wind coming from Trieste, can greatly magnify the effects of the tides. High water conditions can be aggravated by the free flow of rain and water into the lagoon from the drainage basin via the 36 inflow points that are linked with several small rivers and canals. The key advantage of MOSE is that it is flexible and can be operated in a cornucopia of different ways to better suit the characteristics and height of the tide. The gates are designed to function independently of each other and can be put into operation separately. The 3 inlets combined can be closed totally in the case of an exceptionally strong flooding event, while the partial closure of the inlets at a time following the winds, atmospheric pressure, and height of tide is also a viable option. MOSE is built with rows of mobile gates guarding each of the 3 inlets, which can temporarily bar the lagoon from the sea during high tide. The complete structure will comprise 78 gates divided into 4 barriers. The large Lido inlet will be the widest and will be manned there by 2 rows of gates of 21 and 20 elements respectively. They'll be linked by an artificial island that will house the operational center for the gates. The gates are designed as a metal box-type structure with a width of 20 meters wide for all rows, with varying lengths of range 18.5 and 29 meters. The technological masterpieces of the system are the linkage between the gates and the housing structures that guarantees the free movement of the lot. Care has also been taken to ensure that no hassle is faced by the commercial ships that traverse the area. Comment below your views.